Okay, the purpose of this video is to walk you through kind of a cool example of machine learning here where we incorporate both a Matchbox recommender in Azure's Machine Learning Studio as well as some text analytics. This has been done for a while and there's been research papers on this for over a decade, but I'm going to show you how to implement it here in Azure ML Studio. So let's make a new experiment. And the data set I'm going to use for this comes from, let me pull it up here and cite it properly. This site right here, Julian Macaulay from UCSD, they scraped, this is a computer science faculty there, they scraped a bunch of actual Amazon product ratings, including both the product ID, well, I'll show it to you in a second here. This data was way too big for me, so I downloaded just the patio, lawn, and garden data so we could have a reasonable amount to work with and not overload the free tier of Azure ML Studio. But let me make sure I show you the proper citation for all this that I like to use right here. These two. Cite these if you use the data. So let me show you, I think, well, both of them are good. But let me pull them both up actually so you can see them. Here we go. Computer science, these conferences are generally the primary outlet because conference publications are quicker to make it out and more relevant. Anyway, with that, let's go into our experiment. So we're going to call this a Matchbox recommender. Oh, and for those who are wanting to download this who aren't part of my class and just watching it on YouTube, what you need to download if you want to follow along is this 5-core data right here for patio, lawn, and garden. So I'll show you what that data looks like. And I'm going to say with text analytics. All right. So here's my saved data set, Amazon lawn and garden. Let's explore that real quick. So I've got reviewer ID, actual reviewer ID, and their registered reviewer name. We don't really care or need the name right now. ASIN, that's Amazon's internal product ID identifier. Helpful, 01 and 02, I'm not sure the difference. I haven't checked their documentation on the difference in time here, but helpful is a score that comes from, let me pull up a product on Amazon here. Here we go, Alexa. So, all right, no, just give me, I just want to click on the product itself or any product. Here we go, I bought rechargeable batteries earlier. Let's click on that one. So if you look at any product and scroll down, you'll see reviews for the product down here. No, these are the question answers. Sorry, here we go. Here are the reviews. And other people who read the reviews can mark yes or no, this was or wasn't helpful. All right. So here's the actual reviews. In this particular data set, this is the summary here is the title of the review. Product name, I had to write a little script to grab this myself. Their data didn't include it. Their data just had a product ID, or sorry, an ASIN, but I wrote some code to go and grab the actual product name for each of those ASINs. So you don't have to use this. I'm going to use product name in my demo. You can just use product ID and it'll work just the same. I'm only going to use a product name because it's easier to interpret and look at the results somewhat. It's just mildly more interesting. It won't make the actual algorithm work any differently. So let's close that. And what we want now are 3 select columns. So the Matchbox recommender can take 3 different types of data to maximize its predictive capabilities. So at a minimum, it needs the triplet of product ID, customer ID, and rating. Now that can be interpreted in a lot of different ways. To do any type of association analysis or recommendation analysis, you need those 3 things though. In this case, like I say, it's a product ID, customer ID, and rating, but it could also be, like say this was Netflix. It could be a customer ID, a movie ID, and a rating. Or if we didn't collect a rating, it could also be simply number 1 to indicate, the rating could be a number 1 to indicate that they've watched it, or it could be a count of the number of times they've watched it. And that would be sort of a substitute or a surrogate for how much they like that movie. But basically, we need something to group by customers and something to group by products, and then some indication of how much they liked that product, whether it's a movie, a restaurant, an actual product they buy on Amazon, or something like that. Oops, I didn't mean to do that. What I meant to do was go back in here. But what I want to point out is that each record in this first select columns, in each record in this original form the data comes in, represents not a unique customer, not a unique product. It represents an instance of a rating. So that means that in this table, we'll have the same reviewer ID listed multiple times, as you can see right here. The same product ID will be listed multiple times. This is one product. I'm sure we'd find that one again somewhere else in here. But we'll have a unique rating on each row. So that's the format that the data has to be in for the bare minimum Matchbox recommender to work. But that's not the format we want these other two, and we'll get to that in a bit. So for now, let's go ahead and select by name. Well, okay, with rules. We need our product ID. Come on. Sometimes it's a little funny. No, it's not going to show it to me. All right. Let's try this one more time here. I think I'm going to delete this one for now. See if I can run just this. Okay, whoops, one more time. No, can I just run it? No, I won't. So why can't this guy see? Oh, there we go, that's better. All right, so for this we want the reviewer ID, and always in this order, product ID, and the actual rating. So that's where this text comes from. Again, if you're not sure what I'm doing, let me show you the data set one more time. Visualize. So reviewer ID, or customer ID, product ID, and then overall is the name of the column that contains the rating of that product. All right. So let's go ahead and set up. The data in here is already pretty clean, so I'm not going to do anything else to it. We're just going to go ahead and run our split train score. If I just type in recommender, I think I'll get all of them. Recommend. There we go. Train, I'll put it right there. Score, evaluate. All right, so this is a very traditional, the simplest recommender model that I can make. We take those three columns, we put them into split data, obviously change split data to a recommender split. There's plenty of data, so I'll leave it as a 50 and a 25. Pull the training data into the leftmost of train Matchbox recommender, pull train into the leftmost of score, pull the testing data into the second dot here, because this is the data set to score. We score the test data. Then the only thing that's a little bit different from the evaluate model pill is we take score into the right side, and look at the left side. It says this is where the test data goes. Great. This is the right side of split data. Goes right there. So let's get this running, make sure it all works. And then we're going to go through how to incorporate both customer data or reviewer data, which is the equivalent, as well as item data or product data, which is the equivalent. And in the product data, we're going to include or create some custom unique features out of the review text. So this, which is the whole purpose of this example, is to show how to combine a recommender with text analytics. I'll just pause this while this is finished. Okay, that's finished. Let's get our NDCG score, just for reference. All right, 94992, I'm going to copy that. And let's keep track of how our model improves as we start incorporating more and more data types here. Let me do this. So with just the bare bones triplet of just the product or customer ID, product ID, and review, we get a 0.9499. Great. We'll be back with that later. So let's close this out. Now, let's grab another select columns. And here's the problem we're going to run into. The data that we use for reviewer attributes or customer attributes. So it's going to plug in here to training data set of user features, and we also plug it in here in the middle one of score Matchbox user features. That implies, though, that the unit of analysis or each case in the data that feeds in here needs to represent a unique user. Well, the problem is, remember, the data in here comes with unique ratings where the same user can appear multiple times on each row. So we need to aggregate that data somehow to where each record represents a unique user. So let's first decide what features or attributes we want to include about the reviewer or customer. Well, we always have to have the reviewer ID, so it can match up that primary key, foreign key, and tie the data together. But of this data, what is information about the reviewer? The only thing that came to mind, we could probably come up with something out of the text, but I'll save that for later. this helpfulness score. What if we take all of the helpfulness scores for a reviewer and average them together? That would give us an indication of how helpful this reviewer is, generally speaking, in the minds of everybody else who reads their reviews. That's data about the reviewer. But to do that, we're going to have to average those helpfulness scores. So let's just use that one for now, but obviously you could include a whole lot of other things. If a customer is registered, we could also pull any information about them, like where they live, addresses, number of purchases they've made. There's lots of information about a reviewer that'd be useful, but we're just going to stick with one for now as an example. So to aggregate helpful and come up with an average helpful score, we're actually going to write some structured query language, some SQL. So type in SQL over here. So this video is going to assume that you have some background in SQL. If you don't, it's not overly complicated, and actually I've got a chapter in my book you can use for free here. Let me help. Yeah, let's go to this website right here. So I took the book that I wrote for the Intro to Information Systems course that we teach here and broke it up and made it available for free on this website. So if you come here to gamoda.org/ishelp tutorials, data storage and extraction, SQL, this will walk you through. You could do this in about 2 hours at most. A whole bunch of short video clips that'll walk you through the SQL query language, at least enough to be able to write select statements, which is what gets you data. So if you don't already know this stuff, come here and watch those and follow along. If you're in my class and you're an IS student, then you're already familiar with all of that, and we'll head right back here. So click on Apply SQL Transformation, click over here. T1 is the name of the table. It's always the table that is input into the Apply SQL Transformation. So when we select columns, it's a table with 2 columns, Reviewer ID and Helpful 2. And it's called T1, which is nice and convenient. So I'm going to break things on a couple lines here because it makes life a little bit easier. Instead of selecting all, we're going to select Reviewer ID, and we're going to apply an aggregate function, AVG, on helpful, and there's actually 2 underscores in that column name. If you're using that same data set, that was a pain. It took me forever to figure out what was going on. It looks like it's helpful underscore 002, but there's actually 2 underscores for whatever stupid reason. All right, and we got to give it a name. Let's call this new average helpful AVG. There we go. Select that from T1. And whenever we use an aggregate function, that means we have to use a group by statement. So we're going to group by reviewer ID. There we go. So let's run this and just show you the resulting output. I'll pause it. Okay, that's done. Let's take a look. Visualize. Okay, here we have each reviewer ID and all of their helpfulness scores averaged together. Perfect. That's the format we needed in. So next, let's go ahead and drop this down into train, drop it down into score. And again, it has to be the customer info. So hover over this training data set, or sorry, user info. Training data set of user features for both of these. User features. All right. Let's go ahead and run this. Yeah, right down here. Run selected. I'll pause it. All right, let's take a look here. Metric. Cool. NDCG has gone up a little bit. Let's copy that. Bring it in here to our table for comparison. So adding the customer data gets us up to, well, not a lot really. But I mean, it was only one variable, helpfulness, that we brought in, so I guess we can't expect too much. Let me standardize those a little bit. Okay, let's go ahead and add product info now. This is the part that's a little bit more complex, but not bad at all. So if you haven't already gone through and learned the text analytics features, I'd encourage you to do that. You can, if you're not in my class and you don't have access to the book, just go to the YouTube page here under my account, playlists. Come on. Azure Machine Learning Studio playlist. Okay, the purpose of this video... Oh, pause that. And it's down here on the playlist towards the end. Here we go. These last 2 in particular, feature hashing, extract n-gram features and data. And you know what, there's one more I want to add. Let me put it on there real quick. Okay, perfect. If you want to make it quick, go straight to this one.
Okay, so one more.
Azure ML Studio latent Dirichlet allocation. Follow this video if you're unfamiliar with the text analytics, if you need to see how that works beforehand. But we're going to use that right now. So grab another select columns. Perfect. Let's grab just the relevant info. This is going to represent item data. So we need the primary key or the identifier for the item data, which is the ASIN, which matches up with we use that in the original triplet here to make the recommender work. Now grab the review text, and we're going to do some processing on that. So not time for SQL yet. I'll move this up to make a little bit of room for myself. But we are going to want, several of our text analytics tools. So let's grab those. Okay, perfect. First, let's do some pre-processing. Pull that in. This is going to go through and remove stop words. You can pull that up on Wikipedia, a list of all stop words. They're basically words that don't necessarily help describe a topic or that's being referred to in a tweet or a review or something like that. Lemmatization, that converts different versions of a word like run and running back to their base word run, so that we don't treat those as separate concepts or separate words. Text sentences, make sure that we don't look at phrases that cross punctuation. So you detect when there's a period, and so don't include words together on either side of the period. Normalize to lowercase, that's great. We don't want to have two different, the same word with different capitalization treated as two different words. A bunch of other things to clean the data and make it as simple as possible, so that it's we're trying to remove variance in the data. By removing variance, our ability to make predictions, like recommendations, improves. So once we pre-process the text, we're going to do another select columns to get rid of the original text again. So I'm going to pull that in here, and I guess I'm going to have to run, let's see if I can make this work. So we're going to want the ASIN once again. It's not going to be called review text, it's going to be called pre-processed when it's done here. Review text. So the variable name, pre-processed, and a space before it. It didn't work. No big deal. I'll just grab the product ID for now. We'll come back to this one. I just need to run this pre-processed text before I can use that variable. So run selected. I'll pause it. Okay, if I wasn't an idiot, I would have reminded us to launch this column selector here. We got to tell it which text we're going to be running the pre-processing on. So not ASIN, we're running it on review text. Perfect, thank you. Now let's go ahead and do that. Okay, you may be thinking, why did you have select columns up here if you've got one down here? I just didn't think through it. You're totally right. We don't even need that one right here. But let me first come down here and select pre-processed review text. That's our newly generated field now. And grab that. Let me show you what it looks like here before I move on. Visualize. Here we go. Here's the original tweet. Here's what it looks like after it's gone through all that processing. So I is a stop word. It's gone. Let's see. We got rid of punctuation. Yeah. Anyway, because I can't help it, I'm obsessive compulsive. Let's make this perfect. We don't need that one because I've got the select columns I forgot I was going to need later anyway to select pre-processed review text. So let's get rid of that one. All right, what we need next now is a way to analyze the text and turn it into new features. That's the purpose of all of these cool text analytics pills that they've created for us. Now, if you're familiar with this area, we're not going to create, we're not going to do a sentiment analysis and determine sentiment or something like that. They've actually got some better features here. You might recognize named entity recognition. That's a way we pull out topics out of the text. So does this tweet or review refer to a product, an organization, a person, an event, stuff like that? That's useful, but again, we can do better than that as well. Feature hashing, this is what takes the text and turns it into a list of all the individual words. We call unigrams or pairs of words, bigrams, or triplets of words, trigrams. That's also useful, but again, we can do better than that. What we're going to use is this one right here called latent Dirichlet allocation. So what I like about this tool, it's a lot like principal components analysis, if you're familiar with that, in that it's going to take all of our words and boil it down to a set of topics. And we get to choose how many topics right here. We're going to tell it 5 topics. Because if one person says, I really love this garden hose, and somebody else says, I really like this garden hose, those are similar topics. We should group those together, and we can remove a lot of variance that's unnecessary by creating a good number of topics. Anyway, how many should we create? Well, you're going to have to, the only way you'll know, and this is an improvement suggestion they can make in this tool later on, only way you'll know is by trying out a bunch of different combinations. We don't know ahead of time how many topics are truly represented in the data. N-grams, this just says how many do you want to look at. Unigrams, bigrams, trigrams. 2 means we're going to look at all pairs of words, which will automatically include all single words as well. Excuse me. So for a review, I was doing a tweet example earlier. I think for a review, I'd probably use trigrams because they can be a little bit longer, and who knows, maybe there'll be triplets of words that'll be relevant and useful. And it's going to boil all this down to 5. Now, I bet we're going to up that to 10 topics. Okay, let's start there. So now, the output of this, let me show you what it looks like. I'll get this running, and then I'm going to pause it here. All right, let's take a look at the output now. All right, come on. There we go. Transform data set, visualize. So here's what we get. We told it 10 topics. Actually, you know what? I've already changed my mind. 5 would be simpler. But basically, then it looks at each one of these pre-processed texts and said, all right, here's how much this text loads on each of these 10 topics. So let's take a look here. Topic 9 is the biggest one. That means this text is very well defined as a topic 9. This one is low on everything. It gets a little bit higher right here on topic 5, but not super high. Higher on 8 and highest on 9, but not as high as this one. So these I would expect very similar. So like product, sensor work, minute, come, contact, subject, cross path, hard to tell result, live, wood area, a lot of deer. All right, what does this one say? Action yet, husband really like. So again, clearly this is someone who likes it. So these are our new column names. We can use these column names. Remember with, what do you call it? The helpfulness score. Back here when we're looking at customer data, we did an apply SQL transformation and we said, give us the average helpfulness score and group by reviewer ID. Now, the advantage of this one is we can say, give us an average for topics 1 through however many we chose and group by ASIN. So how much does each product have each topic, an average topic score for each? So generally speaking, each product has what type of topic spoken about it or reviewed about it. People write a review about this product that refers to which of these topics. That's what we're getting at. So I'm going to down this back down to 5 to make life a little bit easier on ourselves, because I'm going to copy this SQL transformation, paste it right here, so I don't have quite as many fields anymore to include in my SQL. Let me show you what I mean. So I'm going to have to average. It's called topic 1, and I'll call it top 1. Let's add a comma here. I'm going to go down another line and say average topic 2 and that's the name of the field that gets produced. There's no space in it. Topic 1, topic 2. So top 2, and let's copy all these. Come on. Don't be difficult. What in the world? Okay, whatever. Two, three, 4, 5. So I changed it down to 5 topics. I'm only going to get 5 out of there. Change these. Okay, from T1, it's still called T1 because remember that's the default name used for every data set that comes into an apply SQL transformation. But reviewer ID is not our product. It's ASIN is our unique identifier for product ID. And now I'm going to be super bugged because these don't line up. So I'm going to go ahead and move those back. Okay, oh, one more. All right, that looks good. Let's minimize this. So we've got our SQL transformation applied. Let's go ahead and pull this into, this is where item features go. And this is where item features go. So this says training data set of item features. Technically, all we need is the same random set of data features that come from this split, but it's not a problem to go ahead and put the entire data set into here because it's gonna do an inner join and only use the ones that it needs to run this train Matchbox recommender. Down here, it needs the entire item feature set, so that's where it comes from right here. All right, let's run this one more time and see what we get. Okay, let's take a look. 957. Let's see where that gets us. All right, incremental improvement, but still improvement all the same. So I saw a much bigger effect on this when we were trying to predict retweets from the tweet text and from information about the tweeter. But this is still an important improvement. So kind of cool. That's it. Oh, except I guess I probably should show you here. What do the results of a score Matchbox look like? Visualize. So here's our user ID, and the next 5 most likely items the 5 items they're most likely to want based on what they've rated in the past. Now, of course, if we want to use this in practice, I would change this from rated items to unrated items so that we can predict new products, which means you'd also have to delete evaluate recommender. And you've got to add right here, training data set. Training comes from this side of split data, drop it right into there. Run this guy, and now it's ready to go to predict ratings for future products and set up as a web service.